Welcome to 8.2. In this lesson, we will learn more about different types and characteristics of waves. So let's go wave. Here's a single wave pulse. To generate this wave, we are moving this up and down, but the wave goes right and then left. So we can say that the direction of the wave, which is left-right, and the direction in which we move the medium, which is the balls right here, are perpendicular to each other. When that happens, we have what is called a transverse wave. So here's an example of a transverse wave. We move up and down, but the wave goes left to right. Transverse. Transverse. However, if we push left right like this, that would be a longitudinal wave. So longitudinal. Hand goes left right, wave goes left right. Transverse. Hand goes up down, but wave goes left right. So transverse, longitudinal. Here's an example of a wave. Let's review amplitude and wavelength. The amplitude is this. It goes up to 3. So the amplitude is 3. The wavelength is here to here, or from here up, down, down, up again. So the wavelength is 2. Here's a transverse wave. What would the amplitude and wavelength be? Well, amplitude is how high it gets. We're going up to about 20. So the amplitude is 20. Wavelength, we're going from here to here. So this is about 130, and this is about 290. So the wavelength is about 290 minus 130 is about 160. Okay. We can do the same thing with longitudinal waves. With longitudinal waves, the amplitude is how much we go left and right. If we're going from about 142 to about 162, then the amplitude would be about 162 minus 142, which is about 20. The wavelength, well, is from one part where they're most condensed to another. That's from 0 to about 150. So the wavelength of this wave is about 150 centimeters. So we have V. Let's type it. We have V, which is the velocity, how fast the wave is moving, which is also wave speed. We have F, which is frequency. And we have lambda, which is wavelength. I'll handwrite this one. Wavelength. We use the Greek letter lambda for this. Wave speed might be, for example, meters per second, centimeters per second. Frequency is hertz, which is the same as 1 over a second. The wavelength is a unit of distance, maybe meters, centimeters, and so forth. For example, with this wave, we're told velocity is 400. Well, what we know is that the velocity is the wavelength times the frequency. Why is that true? Well, velocity is distance over time. Distance is basically every wavelength governs how much distance it travels, and the frequency is 1 over a time. So that d becomes lambda, and frequent t 1 over t is f. So that's why v equals lambda f. So we know v is lambda f. Okay. The velocity here is 400. The wavelength goes from here to here. It's about 200. We're going from about 60 to 260. So 400 equals 200 f. Divide both sides by 200. And we got the frequency is about 2 hertz. 2 hertz. And that's it. And that's called the wave equation.